Exponential functions lend themselves well to applications of population growth. Here's a problem. It says since 1978 the rate of population has grown. The growth of the population can be modeled by this equation. The population f of x is equal to 1.26 e. E is the natural base, which is normally used when we're looking at population growth. So 1.26 e to the 0.247x, where x is the year since 1978. What was the population in 2010 if it continued to grow at this rate? So we're assuming that this function models the population growth through 2010. So the key to this problem is to figure out, well, how many years since 1978 is 2010? Well, if we just do 2010 minus 1978, we see that, well, that's 32 years. So we need to plug in 32 in for x into my function. So f of 32 is going to be equal to 1.26 e to the 0.247 times 32. And we calculate this out to get 3,412 wolves in 2010. So this is one application of an exponential growth function. We can also apply exponential growth to the growth of money with interest. So if you deposit money and it grows with interest, it grows exponentially. And there's a formula to model the growth of that deposit, that one-time deposit, which is called the compound interest formula. And it reads A equals P times 1 plus R over N to the N times T. So this formula can be derived by looking at interest being added to an account every so often. But this is the end result. And P is the principal, the initial deposit. R is the interest rate per year. N is the number of compounding periods per year. And T is the time in years. So using this formula, we can figure out what an initial investment will grow to in so many years. So let's take an example. So this formula, this question asks you, calculate the future value of an initial $400 investment deposited into an account with an APR, APR stands for annual percentage rate, of 6%, compounded monthly, that means 12 times a year, after 20 years. So we want to know how much will this $400 be worth in 20 years. So we use this formula and we put in the numbers in the appropriate places. So we have A, the future value, equals the initial amount, the principal, 400, times 1 plus the interest rate is 6%, so we make that 0.06 as a decimal, divided by 12 months a year, close that parentheses, raised to the n times t, 12 times 20. 12 times 20. So if we calculate this out a little bit further, we get 400 times 1.005 to the 240th power. Notice that 400 is the initial value, that's what it's worth now. The base is 1.005 of the exponential function, and we're raising it to the 240th power. So first you have to raise the base to the 240th power, then multiply it by 400. So your final answer is $1,324.08. So that's the future value of your initial investment of $400.